This example comes out of section 1.2, limit of a function. First question, we're asked to find the limit as x approaches 3 of x cubed minus 27 divided by x squared minus 5x plus 6. Always try putting 3 in there, but you'll get 0 divided by 0, so we better be able to do something else. This is kind of your classic factoring problem here. A little bit different than the previous ones in that I have a difference of cubes on the top, so hopefully you're getting a bit more comfortable with factoring a difference of cubes. And the bottom is your standard kind of mat 10 factoring where I have two numbers that multiply together to give me 6 and add together to give me minus 5, so I got x minus 3 times x minus 2. So the good news is that I end up with this common factor of x minus 3 on the top and on the bottom. And that was my problematic factor in the first place that was giving me the 0 over 0 problem. So I can say, well, now this equals the limit as x approaches 3 of x squared plus 3x plus 9 divided by x minus 2. Good news is that both of those are defined when x is 3 and not giving me 0, especially on the denominator, which would have been a problem. So what do I have here? I'm going to have 9 plus 9 plus 9 divided by 1, which equals an answer of 27. So that limit as x approaches 3 is equal to 27. This example a little more interesting, a little different. We've got limit as x approaches 16 of x minus 16 over square root of x minus 4. Definitely a 0 over 0 problem, but nothing jumps out at me as factoring. When you can't factor something and you see square roots, hopefully a thought that you have is, I could rationalize this thing and at least change what it looks like without changing the value of it, without altering it in some other way. So if I do that, I would be multiplying by the square root of x plus 4 on the top and on the bottom. So on the top, I won't even bother trying to multiply that out. I'll just say that it's going to be x minus 16 times the square root of x plus 4. And you'll see why I did that in a second, because the bottom here, root x times root x is x, and this will be a difference of squares, so minus 16. All the inside terms of plus 4 root x minus 4 root x cancel out. So very conveniently, the x minus 16 cancel out, and you end up with the square root of 16, which is 4 plus 4, so 4 plus 4, which equals 8, which is the value of this limit. So while you had the option of factoring things that could factor, in this case you rationalize instead. Along kind of similar lines, we have in this case square root of 25 plus h minus 5 over h as h approaches 0. Can't just put in 0 because we've got 0 divided by 0 problem. I can't factor anything, so my thoughts are, well, there's a square root there, let's try rationalizing. Rationalize the numerator this time, so 25 plus h plus 5, and multiply that on the top and on the bottom. So what does that give me? It gives me the limit as h approaches 0 of, on the top I'm going to have 25 plus h minus 5 times 5, which is 25. On the bottom, again, don't bother multiplying it out. You're going to have h times this 25 plus h plus 5 factor. On the top, what does that give me? It just gives me an h. The 25 minus 25 is 0, so I've got h over h times square root 25 plus h plus 5. Good news, h and h cancel out. That was my 0 over 0 problem, so now I have 1 over 5 plus 5, which equals 1 over 10. The last one of these from 1.2 that I wanted to have a look at is this one. The limit as x approaches 3 of 1 over x minus 1 over 3 over x minus 3. Definitely a 0 over 0 problem, but I can't factor it, and nor can I really rationalize it. It's just, I've got fractions within a larger fraction kind of scenario, which I don't particularly like. So what I would do here is find myself a common denominator for all these ugly fractions that I have on the top. So the common denominator is going to be 3x. You can either combine those by finding common denominator that way. Or the easiest way here actually is to multiply the top and the bottom by 3x. Not breaking any rules, because if you do it on the top and the bottom, you shouldn't change the value of anything. But what is that going to look like? I'm going to have limit as x approaches 3 of 3x times 1 over x is 3. 3x times 1 over 3 is x. On the bottom, I won't even multiply it in. I'll just say I've got x minus 3 times 3x. Now, I don't have a common factor top and bottom unless I do one more quick step, and that is I need to factor out a negative here. And so on the top, if I realize that negative x minus 3 is the same thing as 3 minus x, I've created a common factor, top and bottom, that I can now cancel out. So I've got the limit as x approaches 3 of negative 1 over 3x, and now x is 3. X can be 3 in there, and I don't have 0 divided by 0. I actually have negative 1 over 3 times 3, which is 9. Negative 1/9 is the answer to that problem. So a bit of an unusual one, but this rational expression of a fraction within another fraction, multiply top and bottom by a common denominator, and it saves you a lot of other work.